Welcome to the 10th Standard Physics first lesson, Joules Law. I am Rahul. You have already attended 5 physics classes through the Victor's channel. So here, we would concentrate on the topics which are asked for the examinations repeatedly. You have tabulated energy changes taking place in various electrical appliances. Now let us tabulate the effects of electric current. The useful form of energy into which a device converts electrical energy is considered as the effect of electric current on that device. Now, write this table in your notebook. It is better to write the notes shared through the group in the backside of the notebook. Let's complete the table. Device, energy change, and effect of electric current. Electric bulb. In an electric bulb, we are providing electricity and light energy is released by the bulb. So, the energy change taking place in an electric bulb is electrical energy to light energy. And the effect of electric current utilized here is the lighting effect of electricity. Then in induction cooker, from an induction cooker we are getting heat, electricity is provided. So in an induction cooker, electrical energy is getting converted into heat energy. The effect of electric current utilized here is the heating effect. In a storage battery, while charging, in order to charge a battery, we are providing electrical energy, we are providing current to the battery. As a result, this electricity is stored in the storage battery as chemical energy. So, in a storage battery, while charging, electrical energy is getting converted into chemical energy, and the effect of electric current utilized here is chemical effect. In a mixie, we are providing electrical energy, and the mixie rotates. So, here the electrical energy is getting converted into mechanical energy. So, the effect of electric current utilized here is the mechanical effect. Similarly, in a fan, electrical energy is getting converted into mechanical energy. So, the effect of electric current utilized here is mechanical effect. And in an electromagnet, you know what is an electromagnet? In an electromagnet, this electrical energy is getting converted into magnetic energy. So, magnetic effect is utilized here. Now, in our lesson, we are going to study the heating effect of electric current. Iron box is a familiar device which utilizes heating effect of electricity. Will an iron box get heated up well soon after it is switched on, or will it take some time? It would take some time to get heated up well. So we can say that the heat generated depends upon duration of current flow. If the duration of current flow is greater, heat generated also will be greater. That is, heat generated increases with the time duration of current flow. Will the heat generated be greater when the line voltage is low? It also no. Heat generated will be greater when the line voltage is high, or it would take more time to get heated up if the line voltage is low. That is, and in ninth standard, you have studied that current is proportional to the voltage applied. So, when the line voltage increases, the current through the iron box also would increase. As the current increases, heat generated also increase. So we can say heat generated increases with the increase in current flow. Now let us examine the electrical circuit of an iron box. It has a simple structure. The electricity reaches the iron box through a copper wire, and inside inside an iron box there is a nichrome coil arranged on the hot plate. See here, you can see nichrome coil. Even though the same current flows through the copper wire and nichrome coil, the nichrome coil gets heated up much. No much heat is generated in the copper wire. You have studied in your previous year that the nichrome wire has greater resistance than an identical copper wire. So we can say the heat generated increases with increase in resistance of the wire. So the factors influencing heat generated due to the current flow are intensity of current I, resistance of the wire R, and duration of current flow. It was Joules, it was James Prescott Joule who related these quantities to calculate the heat generated. Joules law. Joules law can be stated using this relation H proportional to I square RT. Actually, this itself is the Joules law, H proportional to I square RT. We can write the statement using this relation. Here H stands for the heat, I the current, R resistance, and T the time duration of current flow. So according to this relation, the heat generated H is proportional to the square of the current through the conductor, the resistance of the conductor, and the time of current flow. So the Joules law can be stated as the heat generated in a current carrying conductor is directly proportional to the product of the square of the current I, the resistance of the conductor R, and the time of current flow T. That is H equal to I square RT. Now can you complete the next table? Here resistance of the conductor R is varied in various instances. Current I also is varied. Time is also varied. What will be the heat generated and what will be the change in heat? You can see for the first time, let the resistance be R, current I, and time T. The heat generated will be I square RT. Now, if you are changing the resistance to 2R, then in the equation I square RT instead of R, we must write I square into 2R into T. So we will get 2 times I square RT. So the heat becomes twice the initial heat generated. Now in the third instance, the R is kept unchanged, whereas I current is doubled so that it becomes 2I. Time of flow is also remain unchanged. What will be the heat generated? We know H equal to I square RT. When I is doubled, instead of I we must write 2I. So the equation becomes H equal to 2I whole square into RT. So this will be equal to 4 times I square RT. That is, when the current through a conductor is doubled, heat generated becomes 4 times the initial value. Now, can you complete the table? Remaining portion of the table is given for you as an activity. You should copy this table. You can see this in your textbook also. And then you should check it. We will publish correct answers in the group. Now, equations for calculating heat. We know H equal to I square RT. Here I square can be splitted into I into I, so that we will get H equal to I into RT. It is equal to I into IR into T. We can either multiply I by I, then we can multiply it using RT, or else we can first multiply I and R, then we can multiply it by I and T. But this IR, we have come across this IR in our last year. From Ohm's law, we know IR is equal to V. Ohm's law, we should always remember this law. So Ohm's law can be studied using this triangle. In this triangle, this triangle is divided into 3 parts. In first row, we have written the letter V for virus. VIR. VIR, virus. VIR. Then, in order to calculate or get equations for V, I or R, we can just cover that value. For example, just cover V. So we are left with I and R in the second row. So you must multiply I by R in order to get V, voltage. If we want to calculate I, just cover I. Then there is V on upper part and R in lower part. So it must be read as V by R. And in order to calculate resistance, just cover R. So you have V by I. Now, according to Ohm's law, this IR is V, voltage. Hence, H equal to I into V into T, where V stands for IR. So we are getting a new equation, H equal to VIT. So we have two equations now, H equal to I square RT and H equal to VIT. There is a third equation, C H equal to I square RT. Again, according to Ohm's law, we know I equal to V by R. Instead of I, we can write V by R. Then it will be H equal to V by R whole square into RT. V by R whole square. It will be V square by R square into RT. 1 R in the numerator and denominator gets cancelled. So we are left with H equal to V square T by R. H equal to V square T by R. So we have three equations in order to calculate heat generated. H equal to I square RT, which is the Joules law, and H equal to VIT, and H equal to V square T by R. These three equations are very important. There will be numericals. While solving numericals, we should always remember that T in this equation must be taken in seconds. T should be taken in seconds. I is measured in amperes, R in ohms, volt, V in volts, and H you will get in joules. So problems will be given in the group. Do it and check the answers which will be posted in the group itself. It is all for today. Thank you.